Charlie doesn't like it to come in there. I left his door open last night. Miko doesn't go by Andrew. It's very interesting. Andrew loves the cat. However, Andrew is constantly in the cat's face. And so, if like I would open both of their bedroom doors, Miko would choose to go into Charlie's room.
Why didn't you see Charlie that much before?
Because Charlie is calmer. But we're recording this, yeah. Yep. All right. So here's our note page for 3-4. Okay, so this is, I think there's an example like this in your book. It's in the new book otherwise. So let's say I told you there's a dynamite blast that propels a heavy rock straight up with a launch of 160 feet per second. Here's the picture of this. Uh-oh. Okay, so, I mean, the height is straight up and straight down, but because of the force of gravity, hopefully from last year, you remember the stuff like this. This is the negative 16 is because of negative 1/2 times g, where g is negative 32 feet per second. And this is the initial velocity. Okay, so, do you understand how I got then the velocity equation? What's the relationship between velocity and position? Okay, velocity is the derivative, so does that make sense then? I took the derivative of the position, 160 minus 32t.
Yeah.
Connor, can you do me a favor and close the door while you're out? Okay, so I just want to point out to you the relationship between derivative and function, because at some point I won't ask you to use the original function, I'll use the derivative, okay? The question is, how high does the rock go? This is the position graph. Would you agree how high the position goes would be the maximum?
Yeah.
Okay? I want you to look at now wish I had a different highlighter that worked.
Yeah, Ms. Palmer, you're teaching us physics now.
It is. Physics and calculus. Calculus is the math of physics. Do you guys see that this is the green line is the derivative, and what the maximum is when the derivative reaches 0. I hope that makes sense to you, because over here, the reason why this is above the y-axis is because what is the function doing? It's going up. That means its slope is what kind of number? Positive. So the reason that this is up here is because this is representing a positive slope. It's above the x-axis. Now, is the line itself slope? No. I'm just saying those numbers represent a positive slope. This represents the maximum, because it's when the velocity is 0, so the velocity has changed direction. And down here, this then represents when the rock is now traveling downward, because these values are below the y-axis, so this is when we have a negative slope. Brett, did you have a question? Okay. So my question then is, we can tell from the graph, and we can do this by plugging it in if we wanted. So, if I were to solve when this was 0, wouldn't I subtract 160 from both sides? And then I divide by negative 32, and I get 5. At time equals 5 is when the velocity is 0. If I would put t equals 5 into this equation, it looks like the maximum is 400, correct? So for how high does the rock go, it's just s of 5. What I want to point out to you, though, is if I didn't have a graph of the original function, I didn't find the 0 by using the original function. I found the 0, which is the maximum, by finding the 0 of the derivative. All right, what is the velocity and speed of the rock when it is 256 feet above the ground on the way up? All right, so there are basically going to be, I need to find when it is 256 feet above the ground, and then I also have to find put that time into the velocity equation. So can't I put 256 in for the position and solve? Let's do that. I'm trying to find at what time is the rocket at 256. What would I do first? No.
Oh, factor. Oh, minus 56.
I'm going to rearrange this. I don't like that. I'm going to do negative 16t squared plus 160t minus 256. Hey, can you guys check and see if, I don't know if this is a nice number or not. Does 16 go into 256? Yeah. Oh, cool. It does? 16. Oh, it, okay. So I'm going to factor out negative 16. And then I have t squared. This would be minus 10t plus 16, right? Ooh, cool. I can factor it then. Can't I use negative 8 and negative 2 multiply to be that? Okay, yay. Alright. So, if remember I'm setting this equal to 0, what are the 2 times that it hits 256? 2 seconds, and just because we know what the graph looks like, that's going to be on the way up, right? And then 8 seconds is going to be on the way down. Cool. Now I don't have enough room, though. Because the question was, what is the velocity and speed of the rock? Alright. So, velocity, what equation is that? This. So I'm going to find v of 2, which means 160 minus 32 times 2. What is that? Okay. 160 minus 64. Okay. So, what would be the units on that? Yep, I'm writing it. Okay, and then how do I find the speed?
The derivative is that.
No, the absolute value. So the speed is also 96 feet per second. Okay. Now, because it's symmetric, make a guess at what the velocity is going to be at 8 seconds.
No.
It's going down.
Negative 96.
Yeah, but let's just do it. Okay, so this is my it asked for the speed and velocity on the way up. Now let's do on the way down. I'm going to do it down here. So the velocity is going to be of 8 seconds. That's what we found from part 1. 160 minus 32 times 8. And it's negative 96 feet per second. And the speed, I just make it positive. Because the rock is still going at the same speed, it's just going in a different direction. Does that make sense a little bit to tie in original velocity, speed? Okay, now can you tell me what c is? What is the acceleration of the rock at any time during its flight?
Right?
Yep, you're right. He said the acceleration is the derivative of the velocity. The velocity function is this. What's the derivative of 160 minus 32t? Careful. Negative 32 feet per second squared. And that just means for the entire time, that's the acceleration. Okay? Let's look on the back. Oh, when does the rock hit the ground? we would find when it's 0, right? You can see from the graph it's 10 seconds. So it's when S of t equals 0, 10 seconds. Okay, let's take a look at this. A lot of times I would like you to do things that can be done algebraically. The derivative of this number 20, it's not in your book, it's the new Jimana book. This, we can do the derivative and double derivative algebraically, but do you know how we could factor and find the zeros of this algebraically? I don't know that we're going to be able to do that on this one. They're not going to be nice is what I'm saying. Alright, here we go. The position x-coordinate of a particle moving on a line is given by, so we're going to, this is it's moving on the x-axis. Positive velocity means it's moving to the right, negative velocity means it's moving to the left. Okay? And we are talking about t is greater than 0 in seconds and x is in meters. Find the instantaneous velocity at any time t. Would you do that, please? Find the acceleration of the particle at any time t. The acceleration is going to be the derivative of the velocity. Okay, how are we feeling about that? So I'm asking you, when is the particle at rest? What does that mean in terms of calculus terms? When what's 0? Okay, so we're trying to find out when is the velocity equal to 0. Okay, so I am going to take my velocity equation and I'm going to set it equal to 0. Now, unfortunately, this is not factorable. So the only way to do this algebraically would to be using the quad formula. So let's do it a second, and we'll get some approximates. Are you singing the song, Sylvan? Yeah. Good, I like that. I thought I heard some humming over there. I could. I sometimes sing it to myself too. Alright, so instead of x of t equals the opposite of b plus or minus square root. Alexis, do you know the song? And Joe, do you know the song? You haven't? Oh, Jobin will, you have to sing for, Jobin will have to sing it for us later. Okay. So let's do the square root. These are going to be approximate. Okay?
Never sing again.
Be nice. Okay. I'm doing what's underneath the square root here. I get square root of 28. If I wanted to use that, take out a perfect square, I could take out a 4, couldn't I? Yeah. So I'm going to just write this as -4 plus or minus, I'm just doing this so you see what I'm doing. Oops, the square root of 4 is 2, right? Okay. Can I reduce these things? Well, Brett, actually, I can. They all are reduced by 2. So this would be like -7 plus or minus 1 root 7 over -3. Now, that doesn't mean a whole lot to us. Let's figure out what those things are. -7 plus the square root of 7. You have to divide the whole thing by -3. And remember, in calculus, and the AP board wants us to round or truncate to 3. 1.451 seconds